We were told that the limit of artificial intelligence was human memory. For years, the race was about size. If we could only build larger context windows, models that could read millions of words in a single breath, the need for external searching would disappear. But this was a mirage. Massive context windows are financially ruinous, slow, and suffer from a strange cognitive blindness, dropping critical details right in the middle of their focus. The real revolution is not happening inside the model weights. It is happening in the invisible architecture built around them. To understand how an AI retrieves information, we have to look at vector embeddings. When you ask a question, the system translates your words into numbers and searches for the closest matching numbers in a database. It is a mathematical game of hot and cold. But this approach has a structural flaw. If you ask a complex question, the math naturally pulls the closest matches. But because those matches are close, they often contain the exact same information. The system handpicks 5 different documents that all tell you the same single fact, leaving no room for the rest of the puzzle. Imagine hiring a private detective to solve a complex missing persons case. Instead of bringing you a bank statement, a flight log, and a witness interview, they return with 5 identical copies of the exact same flight log because it was the easiest document to find. This is the redundancy trap of early retrieval-augmented generation. To break this loop, researchers developed a framework called Vendi-RAG. Instead of blindly choosing the closest matches, it uses diversity algorithms to force the system to select documents that are both accurate and completely different from one another. It balances relevance with variety, ensuring the AI does not get trapped in a room full of identical mirrors. Even with diverse data, traditional retrieval systems fall apart on multi-hop questions. If you ask who designed the building where a specific historical treaty was signed, the system cannot find the answer in a single pass. It does not know the name of the building yet, so it cannot search for the architect. It is a logical dead end. Traditional architectures fetch everything at the start, make their best guess, and hope for the success of the output. When forced to connect disparate dots across multiple databases, these systems collapse. This limitation led to active, iterative refinement, a method pioneered by frameworks like FAIR-RAG. Instead of retrieving data once and running with it, the system acts like a real detective. It retrieves an initial clue, analyzes it, and explicitly looks for evidence gaps. If the first search reveals the treaty was signed in the Hall of Mirrors, the system pauses, notes that it still lacks the architect's identity, and launches a second, targeted search specifically for that missing piece. It is an active loop of self-verification, querying, and parsing until the logical chain is unbroken. But how does the system know which logical path to trust? The answer lies in combining retrieval with slow, deliberative reasoning. Using architectures like RAG star, systems are now integrating Monte Carlo tree search, the same algorithm used by chess-playing computers. Instead of generating a single stream of text, the AI constructs a tree of possible reasoning steps. At each branch of the tree, it retrieves external facts to verify if that specific line of thought is true. If the retrieved data contradicts the branch, the system prunes it and explores another path. It is no longer just predicting the next word. It is simulating and verifying its own thoughts before speaking. These architectural shifts are not academic exercises. They are being deployed where mistakes are unacceptable. In heavy engineering, companies are using these frameworks to build digital minds that preserve decades of operational knowledge from retiring workers, preventing catastrophic plant failures. In Japan, researchers are applying iterative retrieval to medical litigation, where the system must navigate thousands of pages of conflicting healthcare laws and clinical trials to verify claims. In these domains, a hallucinated fact is not a minor inconvenience. It is a multi-million-dollar liability. The future of AI is not a single, giant neural network that knows everything. The future is a silent orchestration of classic computer science algorithms, database searches, and dynamic reasoning loops. The language model is simply the engine. The retrieval architecture is the steering wheel, the brakes, and the map. By grounding neural networks in structured, verifiable external data, we are building systems that do not just mimic human speech, but respect the boundaries of truth.